Here's a question that involves estimating the volume of distribution. TJ is a 24-year-old woman who weighs 55 kilograms. She is given 30 milligrams of the newly approved drug Sparkle. After an IV bolus, you collect plasma samples at the following times. Here are the times and hours after the IV bolus was given and their respective plasma concentration in milligram per liter. At 3 hours, the plasma concentration is 2.5 milligram per liter, at 6 hours, 2.1, at 12 hours, 1.3, and at 22 hours, 0.08 milligram per liter. The first question is asking to plot the data using a linear graph plot. It may be helpful to review the log graphing section first. So first we would label our axes. Vertically, we have concentration in milligram per liter, and horizontally, we have time in hours. Looking at the data points, I determined the best way to space out my time plots and then concentrations that fit the data. I decided to space my time by 5s and the concentration by 0.5s. Then I plot the data accordingly. Afterwards, I would draw a trend line to fit the data. I see on this linear plot the data points created a straight line, meaning the data follows zero order, and we will use this graph to make any predictions about our model. The second question is asking to plot the data using the semi-log graph. Following the same steps in the previous question, I plotted the data points and added my trend line. The data created a curved line, confirming again that it is zero order. This example goes to show that it is not possible to add a curved best fit line accurately by estimation. However, a trend line would not fit the data points correctly on a semi-log compared to a linear graph for a zero order reaction. If the data fit a more straight trend line on the semi-log graph, then it would follow a first order reaction. The third question is asking to explain how you would choose the best fit model to extrapolate the initial concentration at time 0. Again, since after plotting the data, the linear graph provided a straight trend, I know that we are working with a zero order model. Therefore, to extrapolate the concentration at time 0, I look at the linear plot and locate 0 on the x-axis, which is when time is 0, and then follow that line up to where my trend line would pass through on the y-axis. After doing this, I estimated a concentration of 2.9 milligram per liter at time 0. This means the initial concentration of the drug in the plasma is 2.9 milligrams per liter. Using this information, I can estimate TJ's volume of distribution, which will help determine how much of the drug will be distributed across the various tissues. I will use the equation volume of distribution, or V, is equal to the dose given divided by the concentration at time 0. After plugging in the numbers, I did 30 milligram divided by 2.9 milligram per liter and got a volume of distribution of 10.3 liters.